Hello, everyone. Welcome to my talk on Android accessibility made easy. This is Vijay. I work at Uber. This is a quick intro about me. I help Uber build their rider app, the app that you use to request cars. I work on maps, annotations that you see on maps, the route lines that you see on maps when you request a car, or when the driver is en route. I work on the search page that you use for searching your destination locations, pickup locations, and I work on caching, some of the architecture components, and mainly user interfaces. But recently, I started working on accessibility, trying to make Uber app more accessible to people with disabilities. And after getting inspired by the stories that I hear from users with disabilities, at a conference called CSUN, it's a conference about accessibility or assistive technologies. One person even told me that using Uber app is like owning his own private car for the first time in his life. So that is the level of impact that you can make if you make your app accessible, especially at Uber. Before Uber, I worked on Yahoo's native mobile ads and also on Yahoo's Aviate home screen app. So these are the key takeaways that you can get out of it when you walk away. You should be able to appreciate why accessibility is important when you think about designing and writing code for your app. Basic understanding of how accessibility works under the hood, common mistakes that you can see on the app and how you can avoid them when you write your app, and how Uber approaches accessibility and some of the unique problems that are solved at Uber, and how you could do a scalable accessibility testing integrated into your CI. So why is accessibility important to you? Mainly because it improves the usability of your app for all the users by using inclusive design, which means you think about all different kinds of users when you design your app. It positively impacts the lives of people with disabilities. And these are the numbers that I got from the Android documentation. 15% of world's population has one form of disability or the other. And that's not a trivial number to ignore. 285 million people approximately in the world have visual impairments. And 35 million people in the US alone have some level of motor impairments. And you can also approach accessibility as a growth strategy. And for Uber, it kind of aligns with its core mission, which is transportation as reliable as running water for everywhere and for everyone. So what are the common accessibility services that comes packed with Android? Of course, you could write your own accessibility service if you want to, but these are the things that comes out of the box. Talkback is basically a screen reader. It's an accessibility service that calls out or reads out the descriptions of your view, which are presented on the screen. The user can use it to navigate between views, select views, and take actions on the views. Switch access is also popular. It's an accessibility service that talks to an external device. Usually, it could be a switch or a pair of switches. If it's a pair of switches, the user will use the switch, the external device, to one for navigating between the views and the other switch for selecting views. So the reason why there is a need for an external device is that the user with motor impairment ailment they can't really use your touch screen. So they could click on the device, but they might find it hard to use the touch screen. Braille back is similar to switch access, but the device will be Braille supported. And voice access is a very new accessibility service announced by Google in this I/O. It is for people with tremors and paralysis, where the accessibility service called voice access, it'll listen for voice commands from the user, and it'll respond to the voice commands. So the user can say go back or go home or select this view, move this view. So it'll listen for those commands and take those actions on behalf of you. So in addition to these accessibility services, there are many accessibility settings like color inversion setting, color correction setting, font resizing, and magnification setting. So when you write your app, you should be aware of the fact that the users with these kind of settings would also be using your app, and you should test thoroughly with all these settings on before you launch it to the Play Store. So what happens under the hood? So from here on, when I say accessibility service, imagine I'm talking about talkback, because other services are pretty much similar to talkback. So when we look at how talkback works under the hood, let's say you have an app with a lot of different views on the screen. The views are capable of sending something called accessibility event. All the views that comes with the Android are capable of sending this event called accessibility event. And accessibility service, like talkback, can listen for these events. And as soon as they get those events, they create an object called accessibility node info. Imagine node infos are kind of like your data model or view model of your view, which will have information that are very relevant to accessibility. So they create that and send it back to the views, giving the view an opportunity to fill more context to the node info. Things like you can add content description or the speakable text of the view. You can add actions to it. You can add events to it, and then send it back to the accessibility service. And then later, when the user is taking an action on that view, let's say the user is clicking or double clicking or moving the view, those events will be the views or the delegate that you write inside your view will get a callback that the user has taken an action. So inside that callback, you can do whatever you want to. Let's say the user, if the view is a next button, you go to the next screen, or if the view is a previous button, you take the user to the previous screen, for example. So that's what happens under the hood in talkback. The good news is all the standard widgets, views that comes with Android, they support accessibility. All the views and widgets, they're all tested. They're all compliance tested or CTS tested. So you don't have to worry about accessibility a lot if you only use standard views and widgets. But that's not really practical. If you take a look at the top apps in the Play Store and test for accessibility, you'll be surprised to see there'll be a lot of accessibility issues, which means we don't really use standard views and widgets. We customize them. Our designers could go crazy and have complicated user interactions. So that's where the problem comes in. So keep in mind, when you need customized views, always try to extend views that are the lowest in the hierarchy. When you go higher up, like when you extend from view, for example, then you'll have to write more accessibility code to make your app accessible. So what are the common mistakes that you could see in the apps and how you can avoid them? Yeah, this is one of the common mistakes. Views without content description, or especially views that doesn't have text or speakable text built in. For example, buttons or image views, image buttons, view groups like tabs or view pager, they don't really come with speakable text by default. So you need to add content description, a meaningful context dependent content description. And when users, when talkback users especially, when they use a mode called linear scanning mode, where they use their hand randomly to understand how your screen is set up, to learn how to interact with your app. If your view has very small touch target, like below 48 by 48, which is recommended by WCAG, which is a consortium for accessibility, they might totally miss out some of the key views in your screen. So it's recommended that you always, or at least have 48 by 48. When you have your user experience that is only accessible by click and drag, that is a problem. For example, pull to refresh. So in this, the next slide, this is a snapshot of Facebook's app. This is a good example of how you should do accessibility. The view that is highlighted here, that's a feed icon. In addition to bringing the feed page or feed tab to focus, it also does this pull to refresh thing. It brings new content. If you don't have that functionality inbuilt, then users with switch access, they can't really click and drag. They can only select. So those users, they would never get new content. They'll have to reopen the app again. So you have to keep in mind that you should have alternate plans to do these kind of stuff. So if you have decorative views like spaces and dividers, then you should try to put content description as null. So if you don't do that, the users will spend more time navigating between views that are not really actionable. Using color-only changes to annotate state changes or to announce state changes. So this is an app that I use to stream podcast. So as you can see here, the highlighted plus icons, they use a blue color to indicate that that particular podcast is already added to my playlist. So that is only color difference between that gray and this blue, and they have the same content description, which means a colorblind person to blue color can totally miss out on that clue. Ignoring results of network request. So when you, so this is a snapshot of Uber's verification screen, where you type in this number, and if it's successful, then it's going to take you to the next page. It's important that you don't forget to announce the failure, network failure or success, or even the loading in progress if the operation is taking quite a bit of time. So the user is well informed and have full context of what is happening in the app. Having state information about the view and also the type of the view in the content description. So you can see here the content description of the button is button selected. The problem with that is Android tends to append these kind of information called accessibility hints in addition to your content description. So you'll end up having redundant content description if you put those kind of info in there. So you should try to avoid that. You should try to put as much context as possible in the speakable text. So you should have what the text is that is going to be spoken of. You should say if the view is selected or not. You should say the selected position. For example, if you have a tab screen of 3 tabs, let's say the second tab is selected, you should say 2 of 3, and then you should say the type of view and also the action to take. If you have media content, especially video, then you should always have controls that are like that'll be controlling your playback, like next or forward, that are accessible. And also videos should have captions for people who are deaf or hard of hearing. There are other mistakes that you can find. You can check it out later. So what Uber is doing, what are the unique challenges that Uber faces, the unique kind of accessibility problems, and how we approach accessibility. So these slides may not be totally relevant to your use cases, so, but you can always draw inspiration from what we do. So this is a screen that shows that your driver, you have requested your car, your driver is en route to pick you up, and it's important that we announce the ETA, the estimated time of arrival. So when the driver is approaching you, we have code something like this, which will announce the ETA. This is a reactive code which at every interval, ETA number of seconds, it flat maps the trip stream, which will have the trip information, and it'll announce the trip information. For deaf drivers, they have settings in their app. The driver app is a different app on the Play Store. They have settings like they can announce that they are deaf or hard of hearing to the rider, so the riders don't call, but instead they might use text messaging to contact the driver. And we also have a setting to use flashing when there is a new request, and not just rely on notification sounds and vibrations that the driver might miss out. Allow block navigation when you have a bunch of when you have a lot of views or a bunch of non-critical views in your screen. So as you can see here in the bottom, this is so this screen that is highlighted as blue, that is a feed of cards that are deep links to other applications. So so when the user, for example, a visually impaired user comes to the app, they want to take a ride, we don't really want the user to go through all the cards one by one and reach to the bottom of the view and then go to taking a ride. That doesn't really make sense. But so the way we fix that is we stop the focus to that level, the block level, and we'll just announce a summary that this is a feed of cards, and if you want to engage with it, then we open up the feed and go through one by one. But at this stage, we'll just allow the user to take a ride. And if the user engages with it, then we'll go view by view and help them. So if your screen is too complicated or getting too complicated, you should think about block navigation. Branching off for talkback users. So this screen is a screen that you use to change your pickup location. So the text view that says 1455 Market Street, that is your pickup location, and the user is clicking on that to get to this screen to move the pin on the map to change the pickup location. But for a visually impaired person, it's too hard, or I would say that mapping technology is not yet there to address that problem. So what we decided is if the user is if user has talkback enabled, then we don't show this mode. Instead, we show a text mode. So basically, what we wrote is a accessibility delegate into that view, the view that showed the pickup address. And if the user is clicking, we listen for a click event. And in both the pickup and destination use cases, we show the text mode instead of the map mode. But normally, it is not advised to branch off for a particular set of users, because you'll have to maintain that code, and then it becomes non-maintainable in the end. So, but if you have genuine use cases like this, then I wouldn't mind putting that there. You should always try to put add more context to your views. For example, when you open Uber's app, you will see a box called where to that you use to enter your destination. By default, it'll just say, if you have talkback on, it'll just say where to and double click to activate. But double click to activate doesn't really make sense. You could do a better job in there. So we add more context, like we have a new delegate, accessibility delegate, written within the view that has where to, and have custom accessibility action, which has a custom content description called change destination and pickup locations. So when the user comes in and taps that where to, it'll say where to, double click to change destination and pickup locations, which has more context than just double click to activate. So you should try to put more context to the user. And this is another example of giving more context. This is a screen that shows the list of products you can use to take your ride. We call out that UberX is selected, then that is 2 of 8 in the list, and that is selected, and that is a view pager. So yeah, we will move on to something called custom view accessibility. So far, all the views are extended from something like text view or a button or a view pager or other view groups. But there will be situations where you would custom draw your view. You would measure yourself, layout, and draw on your canvas. So in those cases, the problem is the custom views are kind of a total black box to these accessibility services, mainly because when you write your own custom view, the accessibility service, they wouldn't know the view boundaries. They wouldn't know your content description and the supported accessibility actions. So you'll have to write extra code to make your custom view more accessible. So you could use something called Explore by Touch helper, and you will have to override these methods to make your custom view accessible. Before getting into an example, the way you do it is inside your custom view. For example, here, the highlighted box in blue is a custom view. It's called as the navigation view in my example, and that view is drawn by me. I draw the circle, and I draw the background and boundaries and stuff. So accessibility service can only reach till that level, and it can't go within that and go circle by circle, and that's what we are going to fix it. So the example, all it does is this navigation view is going to switch between these two panels. If you click on the first or the left navigation view, the circle, then the green screen will be shown, and if you click on the other, yellow screen will be shown. So the overall idea here is, when you have a virtual view, when you have a custom view, you should try to break that view into virtual views. By virtual view, they mean, what Android means is, it's not really a view, but you define boundaries within your custom view, and you assign unique identifiers to identify those kind of views. So when the user interacts with those areas, you map the user's touch point to the custom view or the virtual view. And based on that virtual view, you take actions. So that's how you approach custom view. So the first in the list to override is this method, which takes in the point of touch, X and Y of the screen. And here I break that little box, the box highlighted in the blue color here, into two areas, and I assign unique IDs. In this case, I assign 0 for the left one and 1 for the right one. And I return based on in this method, based on the touch point, I decide which area the user touched. So the return value will be 0 if the touch is more towards the left, and 1 if the touch is more towards the right. This method gives you a list of an empty list to be filled in with a list of unique IDs that you have. So I'm just looping through and adding to the list. On populate node for virtual view, so after the user clicks on the virtual view, you will get an ID for the virtual view and also an accessibility node info. And based on the ID, you should populate the content description of the virtual view. So in my case, if the ID is 0, I will just say panel 1 or panel 0. And if it is the virtual ID is 1, then I'll say panel 1. And I can also have other contexts, like I will add that I will be listening for a click event. Remember, in talkback mode, the user has to click twice to invoke a click event. So at this point, the user has taken the focus to the view, and we get these callbacks. But when the user double clicks, the actual click event will be fired, and this method will be called on perform action. So where you check if that action is a click event, and you will call this method called send event for virtual view, which in my case, I would actually change the panel and paint that with green or paint that with yellow. So you could check out my example. It's in GitHub. So we move on to testing. So how can you include accessibility testing in a scalable fashion, integrated into your CI? These are the options. You could use Espresso and write UI test and include accessibility test in that. You could use Roboelectric unit test. You could write lint rules. You could use an app called Accessibility Scanner from Google's accessibility team. And I can also do manual testing. And I'll be talking about Espresso and how you could integrate accessibility tests into Espresso. The simplest way to include accessibility test is to use AccessibilityChecks, and you call enable. And this code is from the Google's documentation. The problem with this code is AccessibilityChecks is it's a global singleton, and it has this enable method, and that's not really disable. So you can't. So this is like globally enabling your accessibility checks and hope everything is okay so far, and you can catch errors when there are other diffs coming in. But that's not the reality, where if you enable this, I'm sure you will crash a lot of existing test cases. So this is not really practical. So there are other ways. You could write your own JUnit runner and enable that accessibility checks at that level. But if you have a monorepo setup, and if you have multiple apps, if you want accessibility checks only on particular app and not the other app, then that's not really useful. So the way and also you could not do staged rollouts. This is like enabling accessibility testing for all the test cases for all the apps under the hood. But normally you would want to have or take this step by step, open tickets for a bunch of people, make them fix it, and then go step by step. And that's not really possible here. So the way we approach this is by writing an accessibility test rule, which is basically a test watcher in Espresso. The way it works is we wrote a view assertion, and a view assertion is nothing but you'll get a callback when there is any view action performed on that view. So in that callback, we create an instance of an object called accessibility validator, which is from a library that was added to Espresso by Google. So even the class AccessibilityChecks that also uses accessibility validator under the hood. So we decided to use directly, and we would add a suppressing result matcher. The result matcher will maintain a whitelist of views, or the whitelist of offending views, the views that has accessibility issues. So that we do that because we don't want to make everything red and crash all the test cases. So we know that there are problems with these views. We have added these views to the whitelist. We open tickets, block more diffs on those files, and then make the developers or the app owners fix the issues, also remove the view from the whitelist, and then we move on to the next phase. And that is how we approach it. So after you set the matcher, accessibility validator will call check and results, which will do a bunch of tests for you. It could check if the view has a content description or not. Any view in the screen could be checked for that, and it can even check if two views on the screen have same content description, and it can even check if two views have same view boundaries. And these are tests that are too hard to test if you choose manual testing. And other tests are, it can even check for redundant content description. If the content description has words like button or selected, it can call that out. And since it is open source, it is also integrated into Espresso. You can also add more tests that are unique to your environment, and add that to your test suite. So after we add that accessibility rule, we have that whitelist. We know that those are the views that has problems. We open tickets, make people fix the bugs, and then they would also remove them from the whitelist in the same diff if they are willing. And then once that whitelist becomes an empty list, then we are done with phase one. And then we repeat that for multiple phases, and then we move on to other apps in the monorepo. So that is how we did accessibility testing. There are other options, like you could use accessibility scanner. That's an awesome tool from Google. This app can be used by anyone in the tool chain. Like PMs can use it, designers can use it. The way it works is you take a snapshot of the screen, and it can infer it. The accessibility scanner actually uses the same classes like AccessibilityChecks and accessibility validator, the classes that we saw before, to find these suggestions for you. So you could manually create tickets and open these and make people fix it for you. And this is a good tool if you don't want your test on the CI, or this could also be a supplemental test for you. You can also add lint rules. things like if your view doesn't have content description, you can block the dev from pushing inaccessible code into the repo much early in the process. So yeah, that's the end of it. Thank you very much. Uber is hiring Android engineers, especially accessibility engineers. We're trying to invest more in accessibility. And yeah, if you're interested, you can always send your resume to me, vijay@uber.com, and stay in touch. Thank you. And I'm willing to take questions if there's any, or yeah. So when you enter the code to verify your account, if you have used Uber's app to onboard into the app, we make a request call to make sure you are the person, you are the right person. So when it is going, when the network is in flight, you could announce that we are checking, or the network call is in progress. And you can also announce that if, in this case, the result is the SMS passcode you have entered is incorrect. So in this case, initially we weren't announcing it. And normally, you write content descriptions for your views, and that's all you do for accessibility. But that means if you only write, if you only add content descriptions to your view, you are requiring the user to take the focus into that view which has that text called the SMS is incorrect. But the user wouldn't do that. So those are the state changes that happens in the background. So you'll have to announce those kind of information.
Do you know a way to detect the number of users of your app who do use accessibility services?
There is no such support from platform, from Android, but we have our own custom monitoring. Yeah. Okay, cool. You can find me offline. You can ask your questions. I'll be willing to help. Thank you very much.